Welcome to Econ in HD. My name is Phil. This is Hotelling's Law. First off, to clear up any confusion, this is not going to be about Hotelling's rule. That's something completely different I won't be discussing. Hotelling's Law is something that you'll hear about in like a game theory course or maybe a business product management course. Has to do with the principle of minimum differentiation. Osborne also used the same idea in Hotelling's model of electoral competition. And the idea is simply that what we're going to use is a political spectrum, but we can use distances if we like as well. And it just means that everybody fits onto a line like this. So whether this be distance, like the length of a street, I've heard it also explained as sort of the length of a beach. We're going to use the political spectrum. So if you asked everybody to rank their opinion on a certain topic, and you put them all in some sort of quantitative spectrum, it would end up like this on a single line. And there's a halfway point in all of these, which is the median point. And the idea is that we're going to use politics, but it could be two vendors. People often use this to explain why two gas stations are so close together all the time, why they're always sort of on kitty corner to each other or beside each other. And so we'll take two political operators, in this case, 1 and 2. And the idea is that every person, like every point on this line represents a person, and they position themselves along this political spectrum. Now, every single person follows a very strict rule where they only vote for the person that most closely shares their opinion on a certain topic, which means that for number 2 over here, he captures all of this. Number 1 captures all of this. And say these are sort of equidistant from the center. This distance between them is actually split 50-50 between them because half the people are closer to here and half the people are closer to here. So number 1 captures those, and number 2 captures those. So at this point, they're both equal in the number of people that were going to vote for them on a certain topic. Now, let's say they're trying to decide, okay, if this was the situation and number 1 decides, well, you know what would be a good idea? I bet if I move to the center, I could capture more people. And they're correct. So he moves to here, and they capture everybody over here. Number 2 hasn't figured it out yet. They haven't moved yet. They haven't decided to move yet. And so they capture everybody to the right. And now the ratio remains the same. So you're still getting 50-50 of the distance between them, or all the voters in between them. But in this case, the magnitude is much smaller. So this, number 2 gets half, and number 1 gets half. So you can see that just by moving to the center, number 1 has captured a lot more of the voters here, and number 2 is sort of left out to dry. Now, in this case, this isn't the end result because number 2 knows that number 1 would have done this. So what happens is pretty obvious. Number 1 is like, okay, I'm going to move to the center. Number 2 matches them. Number 2 captures everything to the right. And number 1 captures everything to the left. And once again, let's say these are equal. It's bad drawing. But once again, they're equal. So the idea is that once you reach this point, this is actually an equilibrium. It's actually a Nash equilibrium when you're talking about game theory. But it's an equilibrium because neither of the two players has any incentive to move from this point. So what's happened is they started out here and they've moved in, obviously. But if number 1 decided he might try and be tricky and he moved just a little bit over to the right, he then loses everybody over to the left here because they're now closer to number 2. So both of them would sort of come to an equilibrium point right in the middle here. And so this is why a lot of people sort of think that a lot of politicians will all sort of move towards the center as an election approaches. But it also is applied to distances. So like I said, there is an example where this is the length of a beach and these are ice cream vendors. So both will just set up shop in the middle. And the other thing is gas stations. So people say that, two gas stations will always be right beside each other so that they can capture the maximum number of people, assuming that people just go to whatever the closest gas station is. So that's the basic explanation of Hotelling's law. Thanks for watching.